Hello, I'm Dan Campbell, a senior consultant with Esri Canada's Urban Design Solutions team. Today, I'm presenting the first of 3 videos on 3D in ArcGIS Urban. The first video focuses on the 3D feature object. Video 2 will cover a bare-bones approach to 3D in ArcGIS Urban, and our final video will cover working with 3D content from ArcGIS Urban in game engines. An essential component of your ArcGIS Urban work are the 3D models of existing and proposed buildings and the public realm of your city. The more visually accurate these models are in representing the real world, the more engaged those viewing the urban model will be. Buildings are represented in different levels of detail in ArcGIS Urban. Existing buildings are mostly level of detail 2. Generated plausible buildings have their unique representation. Future buildings are represented in basic level of detail 1 form, and buildings that are added as part of a scenario design visualization or scenario design context are often level of detail 3. It is those more detailed models that we are focusing on today. Let's pan over to the park and we'll take a look at some 3D models of cars. This is how they look in ArcGIS Urban. Now we're actually going to switch over to ArcGIS Pro to see how they were created as 3D feature objects. Okay, here are the car models in ArcGIS Pro. What you are looking at now are the models in the familiar multi-patch format. Multi-patch features have been the most common way of representing 3D objects in ArcGIS Pro and ArcGIS Online. A multi-patch feature is a GIS object that stores a collection of patches to represent the boundary of a 3D object as a single row in a database. Let's look at the attribute table for these multi-patch objects. As you can see, the default attributes for a multi-patch object are limited. Now I'm going to turn on a layer to show you the same original car models visualized using the newer 3D object feature class. At first glance, it doesn't look that different, but you will notice that the 3D feature object cars have actual reflections as opposed to the multi-patch, which have some baked-in simulated reflections. If I adjust my viewpoint or the angle of the sun, the reflections change accordingly. That difference is because 3D feature objects support PBR, or physically based rendering materials. PBR is a method of shading and rendering that provides a more accurate representation of how light interacts with surfaces. These materials exhibit shading properties for surfaces such as glass and metal. A PBR material can simulate any kind of physical material such as tiles, various types of wood, concrete, metal, facades, and backdrops. It does so by accurately simulating diffuse and specular reflections and refractions between surfaces. One of the key benefits of the 3D feature object and PBR materials is that the integrity of the 3D object's material can be carried through from the originating 3D application through the ArcGIS environment and to finally game engines. This enables workflows like the visualization of ArcGIS Urban content in a game engine like as shown here in Twinmotion. So what else has changed? A lot is happening under the hood that can offer you benefits in performance and productivity. Let's look at the attribute table for the 3D feature object version of the car models. As you can see, 3D feature objects have many more attributes than a multi-patch object, including specific georeferencing data. Opening up the properties confirms that the model is a 3D feature object version 2. A 3D file can travel the full length from its original creation in a dedicated 3D modeling application to ArcGIS Pro, then ArcGIS Urban, then ArcGIS City Engine, and finally to a game engine maintaining the integrity of its PBR materials. We have already covered the benefits of the PBR materials, so let's look at the benefits of texture optimization. In a multi-patch, the texture is stored for each feature independently, and the memory used for rendering the features requires loading the geometry and the textures in one stream. The 3D object feature layer stores shared textures only once and can load the textures separately from the geometry, allowing the same data to be stored and processed more efficiently. This is especially beneficial for textures that are repeated multiple times, as is in the case of multiple tree models across a full city model. Also, texture optimization for a 3D object feature layer can be used without an associated 3D model. Finally, let's look at the very powerful feature of the 3D object of being able to edit the models in the source 3D application. While a 3D feature object can be edited directly in ArcGIS Pro with any of the familiar multi-patch editing tools, often it is desirable to take advantage of the expanded functionality of a dedicated 3D modeling application. As well, being able to work with a modeling application in conjunction with ArcGIS Pro opens up the potential of staff who are not comfortable in a geospatial environment but have good 3D skills being able to work in an efficient, holistic framework. Let's start with a generalized overview of how all the pieces work together. It first starts in Windows, where you will need to activate some functionality, and I will show you how in a bit. When this functionality is enabled, it provides access to a projected file system that allows ArcGIS Pro to interact with virtual folders, allowing dedicated 3D applications to be integrated into your workflows. The virtual folders and files you will be working with are in a dedicated Windows folder called 3D Objects. Within the 3D Objects folder is another physical folder called Esri 3DFO. When an ArcGIS Pro project with 3D feature objects is opened, virtual folders corresponding to the project become available in the 3D Objects folder. The first level folder has the same name as your ArcGIS Pro project. Within the project folder can be other feature class folders, one for each feature class within the project that contains 3D feature objects. Within each of the feature class folders are a series of numbered folders, with an individual folder for each model in your Pro project. And these numbered folders are the files in the format that was originally imported into ArcGIS Pro. Just remember, when you close your ArcGIS Pro project, your virtual folders disappear. And when you reopen your project, the virtual folders become available again. Let's see how editing in the host 3D application works. You've been working on a detailed 3D model in SketchUp that represents a typical building that would result from some new zoning and design guidelines. That model has been imported into ArcGIS Pro. Then, not surprisingly, there are changes to the proposed zoning. Rather than repeating all the steps of exporting and importing the model again, 3D feature objects enable an easier method. All that is necessary is for the original 3D model to be opened in SketchUp, the changes made, and then saved back to the virtual folder. This automatically updates the model in the ArcGIS Pro project. Much easier. Let's walk through the process. The first thing you need to do is to turn on some Windows features. What you actually want to search for is something called Windows Projected File System. In my case, it's already on. In your case, you may have to activate this. Once it's enabled, then you can check out your 3D Objects folder. If it's not visible, it can actually be found under your C Users folder. If we scroll down, we should see it here as well. Yes, here we are. C Users, my name, 3D Objects. Excellent. Next, we shift over to SketchUp and work on our SketchUp model. We'll initially export this into anywhere in our file system. We're doing it as a collada file in this case. Once it's, go ahead and export the file, and then shift over to ArcGIS Pro. We then need to actually create a new feature class for our 3D objects. We are going to call this one Heritage Houses. And of course, for the feature class type, we want it to be 3D object. Click Finish, and it is added to our project. Now we want to go ahead and actually add in our 3D model under the Create, and we actually want to add an existing model file. And we navigate to where we saved our collada export from SketchUp and bring it into our ArcGIS Pro project, and we will place it into the park. Save our edits, and just explore it and actually see how it looks in place. And it should have all the nice materials that were originally exported from SketchUp. And now if we go into our 3D objects folder, we see the folder for our project. And opening that up, we see our feature class and our numbered folder for our models. And there is our old house. And in subfolders, we have materials and other accessory files. Okay, we go back into SketchUp because we want to actually do some additions to this. We're going to create a very large laneway house, make it somewhat compatible with some pitch roofs using SketchUp editing tools, and we will get the basic volume defined and then go ahead and actually add in the materials to match the existing house. And once that is all done, we will save our SketchUp file to edit it again if necessary. But what we actually want to do now is actually export this as a 3D model. And in this case, we are exporting it into our 3D objects folder. So we navigate back down through the tree till we get to our model in our virtual folder, oldhouse.dae, and we actually want to export it. SketchUp will ask us if we want to actually overwrite our existing file. Yes, we do in this case. And it's been saved to the virtual folder, and almost immediately what happens in ArcGIS Pro, it is automatically updated to show the changes to the building. Now we'll look at what the process is if we already have an existing multi-patch object. In this case, it's the large apartment building, and we will just actually go into properties and confirm that, yes, it is a simple multi-patch object. To convert it, we go to our 3D processing tools and choose a tool called Add 3D Formats to Multi-Patch. For our input features, we choose our apartment building, and then we have the full list of features that we can actually add to our multi-patch. In this case, we're going to use the Universal Scene Description, USD, the Autodesk FBX, and the GLB format. We run it, and a few seconds later, those formats have been added to our multi-patch along with the equivalent 3D models. And we'll actually go ahead and confirm that the conversion has been successful by going back to our properties. And looking at it, yes, it is now a 3D object version 2. And all is good. Now, if we can navigate back to our 3D objects folder and dwell down, we can actually see our multi-patch apartment buildings, and now we actually have the FBX and the GLB file formats there. And if we dig in a little deeper, we will actually find within this folder the USD files. And all those would be available to edit with the corresponding 3D tools. So I hope this has been a good introduction to some of the power of the 3D feature object. Thank you.